Okay, lesson 3.1, parallel lines and transversals. So parallel lines I think are pretty easy, something we're pretty familiar with. The thing that you want to remember about parallel lines is that they must be on the same plane. And that's important because this next term is what we call skew lines. And skew lines are not coplanar. Now these are kind of hard to talk about, but I'm going to refer back to this picture up here. An example of skew lines would be, let me trace here. So an example of a skew line would be the line here FG, the one going up and down, and then the line CD. They're not in the same plane, but they'll never intersect. One's going up and down, one's going left and right. It's a bad description, but really that's what it is. So they're going different directions, but never intersect. That's a skew line. So when we have parallel lines, we have some special angles. So we have, when parallel lines are cut, they're cut by a line called a transversal. And it doesn't necessarily have to be parallel, but we're going to look at relationships for parallel. Also, there are what are called consecutive interior. Those are ones that are on the same side on the inside. Okay, so I'm going to write some different definitions here. Same side and inside. Now, inside because they're interior. Same side, so if I look at 4 and 5, they're on the same side of the transversal. That's the transversal line going right through right there. So same side, and they're both inside of the two lines. In this case, they're not parallel, but could be Q and R. Okay, alternate interior. Those are opposite side, inside. Again, inside because they're called interior, but opposite side, inside. So the examples they give us here are 4 and 6. They're on opposite sides of the transversal, but they're both on the inside of Q and R. Okay, the next ones are called alternate exterior. So similar to alternate interior in that they're opposite side, but they're both on the outside. The word exterior means outside. So the example we have here are 2 and 8. Because they're both outside of Q and R, and they're on opposite sides of the transversal. And then the last ones that we have are called corresponding. Corresponding are same side, one's inside, and one is outside. Okay, so an example here that they give us are 1 and 5. 1 is on the outside, 5 is on the inside, but they're both on the same side of the transversal, the up and down line. So again, a lot of terminology here that you have to know. So again, they give you some examples here. 1 and 5 are alternate exterior. They're on opposite sides of the transversal, and they're both outside. Now, how do you know which one's the transversal line? The transversal line is the one that hits the two other lines. That's the transversal. So let's look at some guided practice down here. It says name angles 3 and 7. 3, 7. They're on opposite sides and both inside, so those are called alternate interior. Alternate means to alternate, go back and forth, so you go from one side to the other side. Let's do one more here. Let's do number 2C, 4 and 8. Okay, so 4, 8. They're both outside, makes them exterior. They're on the opposite side, so alternate exterior. So again, we have examples here of problems, things that you want to look at. So we'll do a few of these, a couple from each group, a plane parallel to plane ZWX. Okay, so if we look at plane ZWX, that is the top of this. So a plane that's parallel would be the bottom. So you have to name points in the bottom. So you would say plane, let's say UVS, because those points are all on the bottom. Let's do number 3, all segments parallel to SV. Okay, so SV goes this direction, left and right. So TU does, SW, or not SW, sorry, ZW, and YX. Okay, next group. Let's do letter B, 3 segments parallel to DE. Okay, so let's find DE. DE is here, up and down, so segments parallel would be AF. BG goes up and down, CH goes up and down. Alright, let's go down to the bottom here. So similar to the practice we just got through doing a second ago. Let's look at 1 and 8. 1, 8, they're both outside, opposite sides, so those would be alternate exterior. Sorry, my handwriting's bad right here. Alternate exterior. Okay, let's do 6 and 7. Let's see, we'll do blue here. 6 and 7. Those are same side, both inside. Same side, both inside. So those are called consecutive interior. Okay, let's go green here. 2 and 4. 2's on the inside, 4's on the outside, but they're on the same side, so those are called corresponding. And then 3 and 6. 3, 6, both on the inside but opposite sides, so alternate interior. Okay, so one last one here. It says identify the transversal corresponding or connecting, each pair of angles, then classify the relationship. Okay, so this gets a little tricky because we have 3 lines. None of them look parallel or anything, so it makes it a little bit harder. So first of all, let's take 2 and 4. So we said the transversal is the line that has to touch both the other lines, or in this case, it's not 100% true, but touches 2 and 4. So the transversal would be line N, because that's the line that, quote-unquote, touches 2 and 4. Now, where are they located? 2 is on the outside, 4 is on the inside, but they're on the same side, so those would be called corresponding. Okay, let's do one more. Let me erase this. And let's do 2 and 7. Okay, 2, 7. So the line that touches both of those is P. So that's my transversal. Okay, 2 is on the inside of N and M. 7 is on the inside, but they're on opposite sides. So those would be alternate interior. So again, a lot of vocabulary here that you've got to know. And then we're going to apply this to relationships with parallel lines in Lesson 3-2.